Let's go ahead and get started. I will introduce the panel. I'm also going to ask each of the panelists to just give some opening thoughts about their experience with and vision for automating data science, and also if they have any thoughts they'd like to throw out to the panel for our discussion today. So we've got two representatives from academia, beginning with Madeleine Udelle from Stanford, our keynote just now. She doesn't get a break. So why don't you go ahead and with any opening thoughts you have.
I mean, I think we've seen a lot of interesting approaches to automated data science, but I think we're in a really new era because of the large language models and the ease with which they, abstract from all of the, pretty nice, data science that you can find just posted freely on the web. So I think that the sort of the baseline for automated data science is actually much higher than it used to be due to these large language models, and I think that it's interesting to think about the distinction between what we can do with sort of very easy baseline models, and then where does that leave the innovations that we need humans to achieve? Like, how do we figure out how to make ourselves useful in the era where the large language models are already able to produce pretty good baseline models, right? Even this very simple, like, non-optimized prompt that I showed you that I gave to ChatGPT produced a fine model. And so it's, it's something to start with, and that's something that, might take, one of my intro data science students, so, that would be maybe their final project almost, right? Even just, what you get to in one prompt with ChatGPT. On the other hand, so in my experience, playing around with this, I mean, there's still, like, deficiencies right now of these models. They actually aren't very good at plotting, and they often make mistakes at plotting. They make plots that look really bad. I view this as a really transient problem as image processing gets better integrated with the language modeling systems. And that's already happening pretty rapidly. So to me, I actually maybe one of the most severe challenges with this LLM approach to automated data science is actually going to be training data. So I wonder how far we can push the LLMs just using reinforcement learning. How do we get expert annotations for what's actually a really, really good quality data visualization? And how are we going to deal with the fact that the wealth of examples created by humans that we find right now on Kaggle competitions or elsewhere on the web? I'm worried that these contributions are just going to disappear. As people sort of feel that this isn't fun recreation anymore now that they're competing with machines that are better than them. It's not as fun to write poetry when your poetry is always worse than, ChatGPT's poetry. So, I mean, I think the sort of the data set for automated data science is actually going to become a real challenge.
LLMs are definitely a theme running out throughout the community and this conference as well. Okay, thank you. So our next up academic representative is Lars Kotthoff at the University of Wyoming, who's currently attending a Dagstuhl seminar and joining us via Zoom.
Hello, can you hear me?
Yep, I think it's good. I think it's good.
Yeah, cool. All right. So I'm in a coming bit of scheduling. We have a Bakshy seminar that is related to automated data science. In particular, we are looking at human-centric approaches to provenance in automated data science. And one of the things we've been talking about all week is kind of this paradoxical nature of what we're trying to do, where we are first automating something, so AUTOML and automated data science, and now we are talking about how can we put humans back in there and how can we make this work better together with humans, in particular in this context of having a lot of visualization people here who intrinsically see humans as a bigger part of their entire process. So there it is very much not automated, and to some extent they are I don't want to say, they're somewhat mystified by this approach that we seem to take, where we want to automate as much as possible and really remove the human as much as possible, because they're really interested in insights and providing insights to the human decision makers. And that is just an inherently not necessarily manual, but less automated process. So we've been kind of grappling with this for a week here, and in particular trying to contrast the approaches for the two communities with respect to automation and whether we should have more automation or less automation, more human, less human. And I'm wondering what the panel's thoughts on this are, and maybe also in the people in the room, if you can put that in the Q&A.
That's great. We've got some questions on the Slido, and we'll come back to this topic as soon as I have introduced the industrial members of the panel. So let's begin with Andreas Müller from Microsoft.
So I think my opening statement was kind of my keynote on Tuesday, but I think not everybody was here for the industry day, so I'm going to briefly restate sort of my key points. And I'm really interested in what the Daxel seminar came up with, because I think it's very closely aligned with what I was saying in some sense. And that I think to really get to automated data science, we need to expand the tasks we are looking at, and looking at insight generation, visualization, and causal inference, as well as machine learning, and see how can we provide tools that help data scientists do these things, and how can we measure how good these tools are. So as I said, we are really good at creating benchmarks. Like, what would a benchmark look like to measure how well a tool assists a data scientist with insight discovery or root cause analysis? And the other thing that I think is important for making automated data science a reality is to get away from the still really pre-cooked data sets we often look at, and go to more non-IID data sets, relational data sets, time series data sets, which really are the norm in most practical applications, and they are kind of quite different from what we usually see in machine learning research.
Thank you. And then last but not least, we've got Eytan Bakshy joining us from Meta. So please.
Great. So I've worked for about 12 years at Meta, originally Facebook, and I interned in 2010 with the original data science team, and was on the original data science team. I think it was among the first data science teams in industry for about 5 years as an individual contributor before I moved into machine learning. And during that time, I never really felt like data science had very much to do with machine learning. And a lot of it, I mean, my goal and the reason that I joined the company is to understand society and how technology is used, and how people influence each other via technology and computer-mediated communication, and how we can use those insights in order to make the service better. And so all of that is about gaining a better understanding of individuals and using large data sets in order to make things better. And so predictive models can be really useful, and one could apply machine learning, but that's only a small component, I would say. Things like causal inference and thinking about non-IID data, and think about the substantive statistical aspects, and applying domain expertise is one of the most important things. And then, if we think back to how LLMs might be affecting things, it's a little bit maybe more like code copilot, where there are these kind of rote tasks that can be automated. And, some of that might be formulating your machine learning model. But what features should go into and how you should interpret that, that's really, at least for now, it seems like something that isn't the domain of the human. And then there are other things where it's really hard to imagine LLMs as being useful, both with respect to having the proper domain knowledge to understand the questions and formulate the questions, but also talking to people and understanding how is this data collected, what are the caveats, and a lot of those things are really important in practice.
Okay, thank you. So this is great, because I think literally every one of you in your opening statements here touched upon this really interesting aspect of this topic of automating data science, which is that we have this human who's we're going to be interacting with, right? So in the machine learning community, it may be tempting to just focus on accuracy or whatever else, but we also have a human we're interacting with, and they have their own experience. So Lars brought up the Dogstool seminar that he's at with human-computer interaction in this the automated data science world. our top voted question on Slido is asking how we can make sure our work on AutoML and automated data science can actually be useful for human data scientists. So, and Andreas mentioned this as well. So what is the right way to measure our impact? Should we be conducting user studies? Do we need to be thinking more about cognition and doing more like social science type of research, or is it going to be purely numbers all the way? Anybody have any thoughts?
I mean, I think it would first be helpful to understand what data scientists do these days. And so what is the distribution of the types of tasks that are involved? How much of it is building these predictive models versus other aspects? And some of these other aspects I would expect occupy even more time than doing feature engineering and formulating the model. I think of AutoML as being most useful to what in industry people would call a machine learning engineer.
So, but that I agree. That task is maybe outside of the expertise of many of the people in the room. Lars, you're at this doctoral seminar with multidisciplinary with people from other fields. So can you talk about how you're building bridges to those communities?
Yes. So one of the things that struck me about this is that other areas in computer science, like visualization, for example, are doing this all the time, right? Because they're faced with similar problems where they don't really know necessarily what the users want exactly, and you can't really measure this quantitatively. So they do user studies. And I think for us as AutoML researchers, maybe we can even take a shortcut and essentially just say that, well, visualization is kind of intrinsic to what we do and how we want to present the results to you anyway. So maybe we can just piggyback on what these researchers and other communities are doing and essentially leverage them to take care of interacting with users, which is generally not something that machine learning people like to do, right? So we don't have to do this ourselves, but we still reap the benefits of this. In particular, because certainly in communicating the results of an AutoML pipeline or an automated data science process, there will need to be some kind of visualization involved, right? Because we cannot simply present raw predictions or something like that. That's just not going to work. So I think that this is, to me, certainly a very exciting bridge that we should be building. And maybe we should be talking more to people on the visualization side and trying to bridge these two communities more. Because I think we can certainly benefit a lot from their expertise with respect to figuring out what the user wants and then making sure that the systems that we build also do this, and then also measuring this to some extent. And maybe they can benefit from the automations that we're using to, at the moment, really do this for the machine learning or feature engineering tasks, or so these kind of things that can be automated more easily. But you could see the same thing for visualizations. And there are already systems that, for example, recommend visualizations based on the data that you have. But this is, compared to what we're doing in AutoML, it's still at relatively early stages, and there's definitely potential there for more automation and for helping the user more in particular.
On that topic, I'd like to ask Madeleine. So you mentioned that LLMs are really bad at plotting. Whereas there's a bunch of excitement around LLMs at this conference, but maybe in this particular area, it's either not the answer or not yet. So do you have any thoughts about how we may move forward?
Yeah, this is really sort of anecdotal evidence. When I was preparing to teach a data science course this spring, I thought, well, should I even bother teaching them how to do sort of basic pandas, right? Or is that already done by the LLMs? And so I did a bunch of experiments trying to get the LLMs to do as much as they could do. And it was in March of this year when LLMs were better than they are now. But what I found is that when I got to the plotting stage, they would make plots where the lines just overlapped. They just sort of didn't understand the semantics of the data set. And it is actually very interesting to see how you need to go back and forth between, right, the numbers in the data and the plot that you're making, right? It's not enough to know what the header is to make the plot, because you need to sort of understand which things are overlapping, right? And you get the feedback, and you learn something about your data set from things that are not encoded correctly in your data set. You learn about problems in your data by plotting it and looking at the results, right? And language models can't look at the results, but again, this is something that's pretty easy to remediate by combining language models with vision models. So I think people often especially in the early days of LLM, they're getting caught up on, the things that the LLMs can't do. And I really would like to sort of think farther than that so we can get ahead and figure out what we should be focusing on, as a community. And we need to be thinking about what the LLMs will be able to do in a year. So I think this is not, the fact that they're not good at plotting is not really worth focusing on, because I think it's something that's so easy to remediate, right? Using the right data and feedback. Now, I think these issues of, maybe the bigger parts of a data science workflow, which are collecting the right data, that's actually much harder to get any machine learning model to do, because we don't know what data to feed it, right? We don't, so maybe how does the human do this? They have to go talk to people and actually figure out what's in the data, right? So I don't know, you hook up your LLM to, you allow it to access email and email a bunch of people who are owners of the relevant data and ask them what's going on. That's much more complicated. So that's something that I think would be much sort of more difficult part of the data science process to automate.
Andreas, you had a thought?
Yeah, I think there's definitely a lot of very interesting ways that LLMs can help. But I think from what you just said, I was like, maybe we can use once the LLMs have vision, maybe we can use the LLM for user studies. If they're if they're as good as data scientists, then they can be the users. But I think even without having LLMs, I think there's things we can do. For example, I think you can measure plots that are bad. If you have crisscrossing lines, if you have overplotting, there's objective things that are bad, but I don't think they're well defined in a way that are measurable right now by the visualization community, or at least I'm not aware. And I think maybe a dialogue with the computer vision community and, sorry, I said computer vision, I mean visualization. Visualization community could be, okay, what are the criteria that we can optimize? Like there are some things we can capture computationally and then we're really good at optimizing them. But you certainly need some kind of user study to figure out what are the things we actually want to optimize before we can run off optimizing them.
Yeah, but I think you're absolutely right that we have to be focused on, designing visualization, right? If we're automating data science, then it needs to be designed for consumption by who, right? Hopefully by humans, unless we're automating the decision making as well within organization. No, hopefully right now the data science is going to be consumed by humans. Now, it's interesting as we've been talking about the idea of user studies, which I think are critical. We've been talking about the idea that data scientists are the ones who are participating in the user studies. And I don't think that's right. We want the decision makers who are ultimately consuming the data to be the ones participating in the user studies, right? If we're automating data science, I think we're automating the data scientists, right? And we need to think about who their customer is, not the data scientist as customer. I'm not so worried about the fact that it's difficult to quantify these features about what makes a plot a good plot, because we've seen that. Right, I mean, this is the sort of the success of RLHF, right, in the large language models. We don't know how to quantify what's a good response to a prompt either, right? But we take some humans, we have them say whether they think it's good or bad, right? And then we can use that either as a reinforcement learning signal, or we could use it to learn a proxy model that we could optimize, right? So, either way, we have a lot of ways to go, but we absolutely do need feedback from whoever the target audience is of the automated data science, right? Otherwise, we can't make progress there. So I think thinking about who that audience is, how you could access them, like those are probably some of the most difficult challenges for a sort of a modern LLM approach to automated data science, is accessing the right people who can give the right feedback.
Yeah, I disagree with the idea that the person who should be evaluating the automated data scientist insights should be, at least initially, the decision maker. Because the decision maker isn't very sophisticated, might not be very sophisticated at interpreting data and what the nuances are. And so I think it's critical to get feedback from somebody who is a domain expert and can evaluate, what is the quality of this analysis, and does this seem like a credible analysis? And we can maybe train off of that and train off of this expert data. And then once we do that, we can then maybe train it to create more comprehensible plots that correspond to what a high-level decision maker would be interested in.
I think this is a really interesting point, right? the decision maker saying, I like this plot, is different from the decision maker actually understanding the data. And so, yeah, you have to be very careful about this, right? This is, part of why large language models hallucinate. They're, ingratiating, right? They like to tell you that you're right when you talk to them. Yeah.
Okay, great. So on this note, I'd like to turn to what has become a must-ask question in these panels, which is whether anybody has a controversial opinion about automating data science that they would like to throw out for discussion.
So maybe I can get started on this because this is not really an opinion as such, but it is certainly controversial because while we were talking about this week, at some point we came to the conclusion that really it's the humans that are the problem. So once we remove the humans from the equation, everything becomes so much easier. We can automatically evaluate everything end to end. So I would like to propose this as the controversial opinion. Let's just remove the humans altogether from the automated data science, and then we can do things much more nicely.
Should we respond to that one, or should we have our
As you like. If you don't find it controversial, maybe there's nothing to respond to. I don't know.
How do you propose to evaluate if the data science is good when you remove the human?
Yeah, I think that this is exactly along the lines of what Andreas said earlier. You just have an LLM, and that tells you, well, it doesn't tell you because you're a human. It tells another part of the automated system that this was a good visualization, right?
I mean, this gets to these problems with truth, right? How do you get large automated systems to preserve truth in the absence of human feedback? Even with human feedback, how do you get them to preserve truth, right? As you said, like the decision maker, even the data scientist looking at it might not know whether you've really covered up something in the data analysis that should be clarified.
Yep.
No.
So one thing that I think this plays into that a point I was trying to make earlier is we need to ground truth actually for analyses to know whether they're true or not. Like there's the truthful QA where we have like statements and we know which ones are truthful. And so if we want to evaluate data science analyses, whether they involve a human or not, we need to have ground truth for what is the correct outcome of the analyses. Otherwise, no matter what's in between, we cannot say if the outcome is good or not. And maybe that involves the domain expert giving what the actual real known answer is, but that seems also, it seems kind of tricky.
So this is an interesting question. Does anyone else on the panel know of a data set or a way that they would construct a data set of good and bad data analyses? Can we get training samples here or not?
Yeah, I mean, you have all of these students and you give them grades on their homework assignments, right?
That's right.
Just do pairwise feedback on on that data set.
No other controversy? Okay, then, so actually this is, we can connect this to the next question here, which is, why do you think there's been so little work done in automated data science compared to other AutoML domains? One running thread throughout this conversation has been a lot of human interaction required to do these studies, questions about truth and gathering, training data, so to speak, for these analyses. So is it intimately connected to these problems, or is there something else going on? What is it?
I mean, to me, if one were to solve the problem of automating data science, it would be like automating science. You would have to be able to engage in some dialogue with an agent and be able to, that agent would have to be able to produce scientific arguments that make sense and are coherent and take feedback from the user. And so that seems like something that could be accomplished at some point in the future, but that would be a very long-term goal. But thinking about things like how can we use LLMs as a co-pilot could be something that we could achieve in the shorter term. Like, I love the idea of generating good visualizations, and it's also easy to imagine how a computer is able to critique the visualization and improve it. So, well, a lot of those directions seem promising, and we've already seen that LLMs can be pretty good at generating SQL queries and a lot of these data collection tasks that are a big part of data science.
Maybe this is my controversial opinion, which is that, I mean, the question was, why haven't we seen more automated data science? And I think the answer is machine learning researchers love working on images, and there's no images in data science, and so machine learning researchers don't like to solve real problems.
So when I think about, doing a project in machine learning, that I'm gonna aim at a publication at a top machine learning conference, the first thing I think about is, how am I gonna show that I beat the state of the art? Because otherwise I won't be able to publish. And I'm not gonna be able to make the plot showing that I beat the state of the art in automated data science. So, like, why would I do that project?
So then it raises the question
facetious. Okay.
But I think this is a valid concern that seems to be running throughout this conversation. So I wonder, what does the panel think that the automating data science having attached itself somewhat strongly to the machine learning community, is that perhaps a mistake where the incentives are not quite right to push the auto DS agenda forward?
Yeah, it might be more appropriate in the Viz community that has a sort of stronger grounding in user studies. On the other hand, maybe the machine learning community needs to move towards user studies, right? And that's sort of the way of the future, as a lot of the core tasks become easier to automate.
Yeah, go ahead.
Sorry, I think that we'll certainly need to integrate more with other communities. And one of those would definitely be the visualization community. But then also when it comes to gathering the data, so social scientists, for example, who can tell us things that we probably should know when we are building our models. And then also, to some extent, policymakers and decision makers, so that we really understand what they're looking for and how we can support them. And that might be with something relatively unsophisticated, where we essentially take a large amount of data and distill it down to 3 numbers or something along those lines. But of course, they have to be the right numbers. And for that, we have to understand what the decision maker wants to do with these numbers. And this is, I think, where automated data science is also lacking at the moment, because we're not really taking that into consideration, because it is obviously very difficult, and it is difficult to find people who actually make decisions using data, who are willing to talk to us, and then also in a kind of back and forth provide the necessary training data that we can actually do something with this.
Yeah. So I think, again, the machine learning conference model, where in order to publish results, you collect a large ensemble of, applications, right? And you have to show, on average, improved performance on all of them. It's just unwieldy. You can't possibly think about, a single lab, using that to publish one conference paper. It's just, the papers per unit time is not high enough for that to be a reasonable way of, for people to use their limited budgets under the current reward model of, certainly academia, maybe also sort of industrial research labs. On the other hand, if you're, so for example, right now my lab is a collaboration with some cardiologists at Stanford, and so they really care about this particular problem of predicting, risk factors for heart failure, and so we're developing new interpretable machine learning methods, and we're in this sort of tight loop where we say, here's the interpretable machine learning method, we ran it on your cardiology data set, what do you think? Can you understand risk factors for heart failure from this? And they say, oh yeah, this is pretty interesting, but I'm confused over here, and then we iterate this and we improve this, so it's a user study, but it's a user study with a user base of 2 cardiologists. On the other hand, then you can actually get the data, you can improve, and if it's if it turns out to be a good sample of the expert population, even if small, then it's a way forward.
I have a specific question about that setup. So, ultimately, I mean, that sounds like a really useful pilot study for getting insights and having a proof of concept. But eventually, that could easily become some kind of high-impact paper in a general science journal or in a medical journal once you recruit enough subjects, and one could even run a randomized experiment as to how it reduces time to decision or failure rates or things like that. So it seems plausible that once you do, I just love the idea of focusing on a particular piece of the domain and then demonstrating that this can work. And then one can work incrementally from there. And actually, if you do that and you can publish the data sets, maybe the broader machine learning community will then have a data set to work with.
How do you imagine such a data set being published? What exactly?
Well, I don't know about
what exactly would you publish? I'm going to have to record all the videos of my interactions with these cardiologists.
Well, no, I mean I was imagining some kind of evaluation. Data.
I think that, this is the benefit of these more qualitative interactions, right? Is that it can be hard to define in advance what you're looking for, what success looks like. On the other hand, it may be that there are other communities that have advanced much farther in doing exactly that and defining these.
Yeah, and there are communities like the CHI and CSCW, a lot of these human-computer interaction conferences. This kind of mixed methods research would be really well received, and there are people who know how to do these mixed methods and can evaluate the work.
That's right.
So there's a follow-up I want to have about this interacting with decision makers and finding it hard to interact with decision makers. For me, so I'm now in the Azure Data Organization. One of the main products is Power BI. I don't know how familiar everybody is with Power BI. It's sort of similar to Tableau, and people will probably hate on me for saying that, maybe, but this is literally a dashboard that decision makers use to make decisions off data. This is the whole purpose of the product. It has millions of users. It's used in companies all over the world, and I feel like it would be a good test bed. Obviously, we can't share any of the data. We can't share any of the logs or anything, so I don't know how exactly we would do this bridge, but this data exists. It's and as far as I know, actually, this product is not that well connected to a lot of the research communities that could help there. And so maybe, I don't know how it would look like to build a bridge, because this is obviously the decision-making data of Fortune 500 companies. They're very unlikely to give it to you, but maybe there's some way we can at least recruit a subpopulation or something like that to see how are these products actually used to make decisions, and how can we support it.
So this raises, I think, a very interesting question, really that's about the norms of this research community. So in computer science generally, there's a norm that the data that the data sets that you're analyzing be public. Right, so that other people can also analyze the same data sets and publish improved results on them in their papers. That's not the norm in all research communities, right? In fact, in biological science, it's sort of expected that you at least embargo the data for a year. In the operations research community where I come from, frequently people will have in their papers data sets that come from that are sort of proprietary, that live inside companies, and they publish results of their algorithms on the data set, but they do not publish the data set. And in order to get permission to use the data set, they have to sign an NDA with the company. It's sort of a deep interaction and collaboration. That's the norm in that research community. And I think it raises the question, right, if there are sort of, if there are these sort of appropriate questions and things that really, matter for more, ML or, more broadly computer science communities that involve data sets that are non-public, should we sort of accept as a community that that's the direction we need to go? Or should we say, no, we insist on publicness, we think this is really sort of core to the DNA here, and it's an important value that we're not going to give up. I'm curious for the thoughts of the rest of the panel.
You're looking at me. I think it's, this particular, I think this would be such a good test bed that we have in Microsoft, but it's also there's actually not that, I don't know if any other company has a test bed that, this is a very popular product, so I don't know, I don't think it, from me as a scientist, I don't think it's good if this science resides solely with Microsoft. Yeah. And so I don't know how to make sure that we have, the plurality of like opinions and approaches. Yeah.
Yeah. I'm not sure if just a single data set is all that useful to the scientific community. Like, just because it worked on one data set doesn't mean that this method is generally useful. If you look at some communities in like Chi or KDD, you might have some cases where the data there's one example where the data set is proprietary. We have some insights, and that shows that the method worked. But then maybe there's an MTurk study or something like that, where you make up kind of a simple task and you show comparable results, and this helps improve the credibility. So I think there are ways of having some amount of reproducibility, but also being able to demonstrate the external validity of that work.
So I think this would be a good opportunity to segue into the next question I'd like to pose, and perhaps the last question we'll see. So we've been spending a lot of time talking about building bridges to other communities, making impact outside of machine learning. I want to swing back to, what here the AutoML community could do. And there's a pair of questions here from Nick and Frank, which are asking, should we be thinking about running something like a grand challenge on building the best automated Kaggle, perhaps driven by like a data assistant LLM that was pre-trained or fine-tuned based on Kaggle competitions? So maybe, there is a huge database of existing Kaggle competitions, and if we treat them as data analysis tasks, then maybe this gets away from proprietary data sets and brings us to something more connected to this community could help drive forward. Any thoughts?
So I think the Kaggle task is not the right task, because it assumes that you know what training and test set are, and it assumes usually like you need to know that what the dependency structure of the data is to validate it correctly. So if you are maximizing accuracy, you can not have a task that actually, where it's part of the task to define how to correctly split your data. You can't do that and also maximize accuracy in the same competition. So I don't think it's a data. There would still be a machine learning competition, and so I think we should come up with other tasks. If we're going to do that, I mean, this is like slightly my other part of the puzzle for me is we should do it on relational data, not on tabular data, because then it's going to be much more relevant to data science. Like maybe a first version is, okay, if we really need to do classification, regression, supervised learning, at least do it all on relational data. And then it's going to be a little bit more interesting. Yeah, there's the Prague relational learning repository is like 30, 40. Yeah, yes, I want to run the competition, yes.
Yeah, I think a grand challenge is really useful to focus the research of the community, and again, I think it's really important to design, make sure it's the right grand challenge and that we're focusing, our efforts in the right place. I think designing evaluations is probably the most difficult part of that, right? Even if you say, well, like, let's use this narrow focus and design a grand challenge to sort of reproduce the kinds of things that Kagglers produce right now, what's your evaluation method? Right? If your evaluation method, for example, uses an LLM, how do you validate that evaluation? Blah, blah, blah. So to me, that seems like maybe the biggest challenge there. But I agree, figuring out how to collect, curate, et cetera, the data is even more important. I'd love to see people, developing a set of data sets like that. That seems to me like a big challenge.
So perhaps to get a little closer to the heart of the question, I think. So maybe the grand challenge is not the right way forward, but what is the best possible way that this community, the AutoML community at this conference, could come together to help push forward this research agenda of automating data science over the next 1 to 3 years, let's say?
I mean, I really love the idea of having your data set be some kind of set of relational tables, and something that involves performing some kind of reasoning about the task and the data, and figuring out how to put that together to solve the task, and then having some kind of other task that is different than that, but similar, such that one can't overfit to that particular process. That seems like a really good next step in terms of automating data science.
Yeah, you could also imagine that so maybe the community here could come together and sort of create a framework for uploading tasks like this, and then open it up to contributions from other organizations that have, say, relational data, that could sort of where the task could be posed, in a language that this community designs, and in that way sort of build up a really good sort of set of problems for this grand challenge.
Lars, any thoughts?
Yeah, I think I agree with what has been said. In addition to that, I would really think that it's not really just this community, not really just the AUTOML community that needs to come together to move this forward, but it's really about reaching out to other communities. So in particular, the communities like medicine and biology and all these application domains where the tools that we're developing will eventually make a difference, or at least hopefully make a difference, right? Because otherwise we might be optimizing for the wrong thing. But then also reaching out to other areas of computer science, in particular visualization, because they have solved at least some of the problems that we're currently talking about, and they are more familiar with things like user studies. So they can actually help us, and we can leverage their expertise rather than reinventing the wheel and doing our own user studies and things like that, and then eventually rediscovering in a couple of years that, oh, this is how we should have been doing it all along. So I think the interdisciplinary aspect is really, really very important, in particular because I believe the AUTOML community is at a stage where other communities can use our tools, right? You can just download an AUTOML tool and you can use it on your data and you will probably get a good result. So that's not really the problem. But how do you integrate that with your processes? How do you make sure that it's actually solving the right problem? And how do you make sure that you, as in particular the domain scientist, can trust what the system is giving you, and you can also affect what it's giving you? So that it's not this slightly bigger black box built on top of machine learning that then gives you a result, and either you like it or you don't like it, and that's really the only choice you have.
Okay, thank you, everyone. Does anybody have any closing thoughts? We are coming to the end of the discussion and moving into the poster session, but we've got time for any last-minute thoughts anybody would like to throw out there.
Very, very briefly, I just want to say, I totally agree with interdisciplinary, at least in the midterm. I think in the very short term, expanding data and focusing on causal things would be really important. If we want to do any challenge or a benchmark or something, having realistic causal scenarios, ideally where we also require to explain the insight, not only saying this is the cause I found and say it as one thing, but also why do we think the data shows this is the cause, because this is what really a decision maker would want. And this is sort of the kind of task I think we should work on in the short term, but obviously in the midterm at least we need to talk to other communities.
Yeah, I think being able to present some kind of argument or insight through the data and show that the agent is able to perform some kind of reasoning from the data would be a great demonstration that we are making a step forward in automating data science. This would be moving beyond prediction and more into the realm of reasoning, which I think a lot of what data science is about.
I just want to say thanks to this panel. I feel like even when I sit on a panel, I don't usually learn so much from a panel and arrive with actionable plans afterwards. But I'm very excited for this new data challenge that's going to involve making causal, decisions from relational data that's a little hard to gather. We're going to make a grand challenge that involves many of these. We're going to solicit input from the community. We're like, yes, we got a plan. I'm very excited for what comes out of it.
So we've all seen a historic moment unravel here on stage. Okay, yes, so we've got our work set out for us, but it sounds like everything's going to be very exciting. I'd like to thank the panel and welcome the audience to join me in doing so.